Okay. So, we begin with number 4. Oh, good gravy. You have seen notation like this before. The squiggly brackets mean it's a set, which means everything inside those squiggly brackets are elements of that set. Yes? Okay. Each of those elements is written in a notation that you are also familiar with. What is it? Coordinates. Coordinates are x and y. Which of those is independent? X. So which of those are elements of the domain? X coordinates. What of those are the x coordinates?
1, 2, 3, and 4.
Excellent. All right. So first we got to decide if it's a function. So we better put up our inputs. What are our inputs? Excellent. Our inputs, that's interesting. Our inputs are 1, 2, 3, and 4. Our outputs are what?
3, 6, 9, 12.
3, 6, 9, and 12. Does each input go to a unique output? Yes. So is it a function? It is a function. Why is it a function? One output per input. Now, here's where it's going to get tricky. What is the domain and range? Now, I've shown you one way to write domain and range up there. This requires 2 pieces of knowledge here, yes? 1, to know which is the domain and which is the range, and 2, to understand the nature of the domain and of the range, yes? So what are the values that I could write in the domain set, which I like to do in blue, and the range set, which I like to do in red? What are the values I could put into the domain set? Fire.
1, 2, 3.
1, 2, 3, and 4. Absolutely right. Now the question is, can I put only 1, 2, 3, and 4? Or can I write something like this, which covers everything between 0 and 40?
Yeah, you can. But you have to do it between 1 and 4.
So Byron is saying I can go ahead and I can put in something like this, which would mean I can have a domain value of 1.7. Does everyone understand what Byron is saying? Now Byron is changing his mind because upon my explanation, Byron has realized the mistake in his thinking. What is it? What did you just realize?
That you can have a fraction. It's because all you get from the domain and the range is a certain set of numbers.
Yeah.
You can't tell you anything outside that.
Does everybody hear what Byron is saying? Okay. So Byron has just noticed upon speaking of it and discussing it that there is no output for 1.7. Because I have an input for 1, I have an input for 2, so I have an output for 1, I have an output for 2, but I have no idea what's happening between 1 and 2. Everybody understand? So I can't write it this way, so I got to write it as a series of numbers. Squiggly bracket still, 1, 2, 3, 4. And we always go ascending, meaning lowest number first. Everybody cool? So what then is our range? Squiggly bracket. Again, we keep it ascending, so what would our range be? 3, 6, 9, 12. Now, this time that happened to work out to be the ordered pairs. It might not always. We just keep it in ascending order. Everybody cool? All right. So let's go to B. Is B a function? Yes or no? No, this is not a function. Why? Right. Because 2 outputs at what input? What input gives me 2 different outputs? Right. Everybody cool? Okay, so now let's do our domain and range. First things first. Is it a series of points or is it a spread of the axis?
Domain is 1.
No, that's not what I asked. Is it a series of points or is it a spread of the axis? It's a series of points. Excellent. So I can't use the greater than less than thing. So what do I got to put? Look and think. -1, 0, 1. Why don't I repeat 0 twice? Because it's just an element of the domain, right? All I'm asking for here is what values can there be for an input. Okay, so what's the range? Now, just like I was talking about earlier, did these -1, -1 make an ordered pair? No, that was not any of the ordered pairs that were there, was it? So do not make that mistake. Domain and range are just values. Okay? Yes. Yes. So let's look at C. You guys figure that one out. Yes or no? And then the domain and range. Go.
You have keys for this time?
I do indeed, Mr. Stew. Where that?
Thank you very much.
Bye, Mr. City.
You'll see him again. I was going to bring my keys back. You guys got this for me yet? Yes or no?
Yeah.
Yes? Domain? Who do we appreciate? Math. Math. Rah, rah, rah. Now you didn't say goodbye to him, or you're not going to see him again. Come on.
Sorry, it would have been awkward if I said it again.
And what's my range? 3, 5, 7, 9. Can everybody handle the series of points? Great. Now we move on to another way we can illustrate relations and functions. From a graph. Remember I told you got to know 5 ways to do it. Looking at that, tell me, what do you know about it? Function? Function or not? Domain and range. Go.
Oh, is it that? We were just going to
I was singing the song.
Yeah, that's the one. Where is that from?
The music that the band is playing in the Star Wars Cantina.
Did you see that J.J. Abrams and Tarantino are partnering up to make a Star Wars movie?
Great. So it'll be a Star Wars movie with lots of people saying the N-word. Spectacular.
Why is that funny? Pulp Fiction. You like that?
I love Pulp Fiction. I think it's one of the greatest movies ever made.
What movie?
Pulp Fiction.
You've never heard of it.
Do we have an answer for me yet? Is it a function or isn't it? Yes and no are not words.
No.
No, of course it's not a function. Why?
Because there's 2 points that are on the same axis.
2 outputs at what input? At which input? At input of -2, right there. So, what is the domain? -3, -2, 0, 1, 2, 3. What is the range? -3, -2, -1, 0, 1, 2. Nice work. Everybody good? All right, now I'm going to do this. I am going to give you a little treat, a gift, if you will. The vertical line test. On a graph. Please notice that I've written the words on a graph. Does that mean you can use it when you don't have a graph? No. When can you use it?
On a graph.
On a graph. You would be surprised.
That's so
Oh, and the next thing I need to make sure, what direction is vertical?
Sideways.
Okay, just making sure. On a graph, if a vertical line, yes, you already asked that. Okay. Up at the front, there's been a toaster there every day you've ever been in this room, and all of you except Byron and Blake have been in this room many. I'm not going to say 108. Not there, but it's been in the room.
Okay. Well, it could be hidden in a cover.
No, it was not in the cupboard. It was right over beside the microwave. I don't care. It was still in the room. If a vertical line hits the graph more than once, it is not a function. Why is it not a function? Right. Because that means there's multiple outputs. At that input. And here is what I mean. There is a lovely freehand vertical line. And now it is going to truck across the page. Darn it! What happened there? There's 2 dots. Poopy. So it can't be a function. Everybody good? All right. The more astute members of the class will observe that the next question is what? A graph. Which means what are you allowed to do? The vertical line test. Giver. Of course it's not a function.
There's two outputs on.
Because when I go, am I okay? Yeah. Am I okay? Yeah. Oh, c'est dommage. And oh no,
Just we.
malheureusement. Je sais.
Just say. Oui.
No. Je ne suis pas français. Tu n'es pas français.
The conjugative verbe.
When you go to Mexico, too, you can ask for Drinko de la Watero as well and see how well that goes over for you.
Is it water like
Agua. Vaso y agua. All right. Now, that being said, domain and range me. Where do I look for the domain? On the x-axis. Where is it? There. 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 And there. Is it -3 blah x blah 3? No. Why not, Sukmin? Half the answer? Why not? Harmon. Exactly. I only have inputs at those spots. So I can only list those spots. Yeah? Yeah. And the range? Where do I look for the range? Up on the y-axis. There, 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 thar, and thar.
Wait, okay. So horizontal is always the input?
Yes, when it's like this. What is my range? -2, -1, 0, 1, 2, 3. Well done, ladies and gentlemen. You did it. Oh no, something new has happened.
Oh my goodness.
Good gravy. What will we do?
Vertical line test.
We will do the vertical line test. Why, Sarah?
Because we want to know if it's a function or not.
We want to know if it's a function, and because it's on a graph. Whoop. Is it a function? Brah, brah, brah,
No.
brah.
No, he's just going, wow.
Yeah, I just...
thought maybe he was telling us we were wrong for saying yes and no.
No.
Yes, it is. Just think, that's still the infinite forever.
Let's pretend that this worked.
Oh,
I recently...
It is a function.
Yes. They are testing self-driving cars in various cities in the United States. The Uber Corporation.
Imagine if the car...
Imagine if the car was powered by a Surface. Fortunately, there is still someone in the car for when the computer stops working. All right, so yes, it's a function.
What's the point of the self-driving car if you gotta have a mechanic on hand at all times?
Well, the point is they're testing it to make sure it's going to work.
Well, of course it's gonna work.
Well, no, of course it is not going to work because, as you can see, computers screw up all the time.
Self-flying plane
It's
or...
called autopilot.
Autopilot only flies the plane. Autopilot cannot land it or take it off yet. It will.
Well, one day, we'll always be killed by robots.
All right, so it is a function, yes, but what has changed?
It's drawn by hand. And
What has changed?
There's no values.
Okay. But the first dot, 1, the second dot, 2. Fine. You could argue that. What has changed between number 5A and number 5B?
There are no little lines everywhere.
Oh,
And it's not numbered.
crash! That's the self-driving car.
Oh my gosh, you're right.
That's 10 Miss Lamb.
So, what is different from the graph of 5A to the graph of 5B?
There's no numbers, so oh, now there's numbers. You just kind of read the point.
I'm not looking for a complex answer here, guys.
There's a line drawn.
There's a line. Thank you. The dots, the points are connected. So, when I look at my domain, where do I go to look?
The horizontal line?
On the x-axis. Right? Okay. So what's my lowest point? On the x-axis. -3. Everybody agrees?
Yeah, I had to count all the signs.
Now, what's the next input? Because I get an output right there. What's the next input? -3 is the first input. What's the next input?
I want to say it's 0.
-2. So at -2, there's an output. There's no outputs in the middle here.
There's outputs everywhere.
There's outputs everywhere.
-3.000.
Other way, we're going up. So -2.99999999999999999 for how long?
Ever.
Right, and then -2.99999999998, and then 2.9999999. So, can we list this as points?
No, we should do that.
No. So we have to do that thing where we say -3 because it starts there, and we notice that it is continually all the way along the axis. To where?
Word 3.
To +3. So -3 is less than or equal to every x I could have. But every x I could have has to be less than or equal to +3. Right? This is what we call set notation. Now listen to me, please, ladies and gentlemen. This gets significantly more complicated in its notation, the way we write it. But for now, the concept that you understand is that this is all the numbers between -3 and +3. Every single number you could possibly have.
Even the impossible number?
Even the root of 0.17, which is irrational. Everybody got it? Everybody understand? Yes.
So that's only if there's a line, leave the line takes that every output.
Uh-huh. Now,
Now what about
fortunately for us, when we have this situation, there's a shorter way to write it than that. We do a square bracket, -3, then we do a +3 and another square bracket. We use square brackets because of this. The square bracket because of this. How many of you remember this in grade 9? X plus 2 is less than 7. What's the answer?
X is less than
S is less than 5. And then we drew the graph, right? 5.
Oh wait, I see what we're doing. Yeah, okay.
I remember.
Now what did we do with that 5?
We can do anything.
No.
No.
I taught my class what you're supposed to do at the end of this.
Simplify.
You make the graph. What kind of dot do I put there?
Oh, you put
The open one.
Open dot, because 5 is not included. But is 4.99999999999999999999999? Yes. So then we would draw this. So you've all seen this before, right? So what kind of dot is that? Is it solid or is it open? Solid. So do we actually hit -3? Yes. So that's why we used a square bracket. What if
I don't like what if questions.
it looked like this?
You shatter my confidence. Is that a
Then
no?
we wouldn't have a square bracket. We would have a round bracket.
Wait,
Everybody
It
cool?
looked like what?
If it was an open dot.
Dippin' dot?
An open dot. Dippin' Dots are ice cream invented by a dude who was actually an inventor of dog food.
No.
Way.
Dippin' dots are like Dippin'
Well,
dots.
that explains why it's so delicious.
So what's the range? Where do we look for range?
Why axis?
On the y-axis. What's my lowest range value? Right there, -2. Do I make it to -2?
Yes.
Yes, because it's a closed dot. So -2 is less than or equal to y, and y is less than or equal to what?
Positive
3. How would I write it in Oh, sorry, I forgot to tell you the name of this. This,
What is?
this,
My learning is being destroyed by this machine. I will never know what that is called.
interval notation. Why? Because it is using an interval of the whole y or x axis. Because, of course, both those axes go to infinity in both directions. And you are using a small interval of that. Okay? So all of you now, knowing what you know, look at C. What's different? There's 2 separate lines. So let's attack what we know first. First of all, is it a function? Yes or no? Yes, of course. Why?
Because the line test works.
Vertical line test works.
Or does it not
Okay,
work?
great. No,
What do
it
you-
works.
So what do you say when it doesn't come up? What do you say when
Okay, everybody cool? All right, the next thing I asked for was domain and range. What is the domain? Well, there is 2.
they just why they do that? Like, what is this for? Is it
Look
really-
closer.
-3.
Look closer.
-2?
Look closer.
Oh, guys.
Look closer.
Is it solid or
Oh,
not?
-30.
-30.
I knew it.
Is -30 included? So what arrow does it get in set notation?
Less than or equal to?
Less than or equal to x, but x is less than or equal to, or is it? I follow along the x-axis, and what do I find? An open dot. So is it an equal to 10? -10? No. It's less than -10. Agreed?
I agree, but how do you write that?
Just like that.
That's it? You don't
Now,
What about 10?
what happens here?
It restarts.
It restarts with what kind of dot? A closed dot. What value is it?
0.
And what does it go up to?
30.
Does it get to positive 30? Now we are in a situation where we have two sets. In math, both those sets are included in the range, so when we write them out, we put a U between them, which stands for union. If we weren't including those sets together, we would have a different symbol. We'd have an upside down U, but that's for set theory. That comes later.
It's like a full cup, and then it's like an empty cup where everything gets dumped out.
Okay. What is this, do you think, in interval notation?
It's negative 30.
With what kind of bracket?
20, negative 20. Square. Negative 20.
Square. No, it's not. It's negative 30.
Only 2 lines.
Up to what? Sarah. 10, 20, 30.
But oh, never mind. I thought we were on the other one.
No. We are doing the range in interval notation.
Okay, yeah.
Negative 10. Round bracket. Union with what's the other one?
Square bracket. 0.
Why is it a round bracket?
Because it's not included.
Because they're empty sides. Oh, okay.
Positive 3. 30.
Excellent. What is the range? Go, Sarah.
No, it's negative 20.
So I go to here. Is negative 20 included?
Yes. But 0 isn't.
But 0
So it's
isn't.
less than, but not equal to 0.
Excellent. Is there more range?
There is. And it's
Okay, which one of you 4 is moving? Because I've been very, very charitable. You don't even have your book out. I know you're getting 99% in my class, but you're also playing with a phone. And you're giggling every 2 seconds, like a 5-year-old. If you wish to be a 5-year-old, continue to be so because you're getting 98%. I don't care. But there are other people in the class who are not getting 98%, who are sitting beside you and who are giggling along with you. So decide now, please. I am taking by your silence because you are being called out in front of everyone that you are embarrassed enough that you are going to shut up. Is that the case? Good. What is this one?
0.
No.
No. What? 3, 4.
No. 10.
30.
Is 10 included?
Oh, yeah. What?
No. Why? Open dot. Then it goes up to what? Is 30 included?
Yeah.
Great. So how do I write it? 10 less than, which is, and y is what to 30? Y is greater than 30? Less than or equal to 30. Now, put that in interval notation. Go. Exactly the same as domain, guys. Use the knowledge that you already have to solve a new problem. Square bracket.
negative
20, comma,
0, round bracket.
round, union,
U and then the
round bracket, 10, yay! No. Unless I ask for one specifically, I don't care which one you use. All right. Yes.
Why would the bracket at the end of the 3 be a square bracket? Like, why would it be a circle bracket? Like, you've got square bracket and then circle bracket, union, circle bracket, and then square bracket.
Because the 30 on the X isn't included.
Okay.
And the 30 on the Y is.
Okay, thank you.
No problem. D, function. Ooh, intrigue. It's a fight.
Because the circle bracket does not, I mean the circle, hollow circle does not include that exact.
There you go.
Fight you on that.
You're absolutely right.
Oh my goodness, that's so mean. You're not including the circles.
What's confusing? The circle dot exists, the open dot doesn't.
It doesn't exist.
No, that's what the open dot means. It approaches it, but it doesn't get to it. So at 3, this one is there. This one isn't.
It's like
At
slightly
negative 2.9999999999999, the output jumps from 3 to that value. Well done, Blake. All right, domain and range. Very, very tricky. Where do I start looking for the domain? On the x-axis. Where on the x-axis? As far left as possible, because I go in ascending order. What is the farthest, the least value on the x-axis? Negative.
9. Because it goes by 3, doesn't it?
That's 3, 6.
Mm-hmm. So 3,
Negative 3, negative 6.
6. Negative 6.
Oh, because the point it's on.
negative 6 is
Is it included? Less than?
equal to.
Excellent. Up to what? Let's go along, shall we? Oh, it gets up to 3, no problem. What happens then?
It stops.
It doesn't stop, does it?
No, because it's.
Because that line keeps going. Oh, crazy talk. To there, and then what happens? It keeps going to there. Is that one included?
Yeah. So less than or equal to.
Less than or equal to 6. Put that in set notation. It's already in set notation. Put that in interval notation.
Other one.
Round bracket.
Negative 6.
Negative 6.
Comma.
Comma.
6.
6.
Square bracket.
Square bracket. Look at you. You're on fire. And range. Where do we look for range? The y-axis. Great. What is the range? What's the lowest y value I can find?
Negative 3.
No.
3.
3.
It was a dash and it kind of makes it look negative.
Oh, okay.
What's the next possible y value?
0.
No.
Oh, no.
6.
6. What's the next y value? 9. Have I colored in an interval of the y-axis or only 3 points of the y-axis? Points. So can I do this? No. So what's the range?
3, 6, 9.
9.
Done.
What's the best time?
Everybody good. Excellent. That makes me very happy. But what does a bunch of blank white space mean? Trickery and jiggery pokery.
There's a square in that space.
Well, that was okay. You can turn that square into an axis pretty quickly.
It's a nice square. Look at it.
Lovely. Let's say the graph does this. function.
That looks like a horrible problem. That does not look fun.
No,
No, why?
Can I not round?
What happens right there? Bunch of outputs. Bunch of outputs. So it's not a function, right? Okay. Domain. Where do I start looking? X-axis.
Oh boy.
Negative 2.
To
Excellent.
positive-
Is it included?
No.
No, it's not.
So then, X. What does that arrow mean?
Forever.
Goes on forever. To where?
Nowhere.
Infinity.
Everywhere.
Will it ever equal infinity?
No.
No. So I can write infinity. Now this gets weird. If negative 2 is the lowest number I can have, write this for me in a simpler way without an infinity symbol that will still mean the same thing. Talk to your neighbor and see if you can figure it out.
Like in Python, you know, like the coding, like if you're writing a function, you just don't give the second variable. Can you do that? So you just give -2 and then leave the second space blank.
Try it. Make that your statement when I ask who came up with something. Okay? Byron also gave me the when do we need to know this in real life answer that I was about to give as well.
Do we ever? And when we're like trying to like trip people out.
Okay, so how could I write this? In this type of notation, in set notation with no infinity symbol. Byron has an answer, but it's better for interval notation, what Byron's answer is. Can anybody figure out a way to write this?
With a bracket.
So this is where it starts, right? And it goes this way. For how long?
Forever.
Ever. So every x must be what?
Greater than
Greater than
-2.
-2. Done.
No bracket.
No bracket. Well, you put a squiggly bracket there because it's a set.
There we go.
But you don't have to have the infinity symbol. One sec, you're about to get your move here. How would I write this in interval notation? What's the lowest x value I can have? -2. What kind of bracket? Round, comma, infinity, with what kind of bracket?
Square bracket.
Square. We would equal infinity.
Round. Well, after infinity, it's
Round. Okay. Now, Byron has given us the real life version of this. That symbol doesn't exist, right? How do we do this on a computer, Byron? Because this is when we use functions.
You just leave a space.
You leave a blank space because that spot doesn't exist. 2 onward. Okay? All right. So what then is the range? Does anything change? Where do we go? On the y-axis. Great. Up or down? Down, because we start at the lowest value. What is it?
we don't know. Because it could go lower in the future.
No, we can't. It points up.
But then it might go down. It just,
It points up.
so we assume that it keeps going
Yes, that's what an arrow means. So, what is the range?
down. -2.
Okay, -2. Now you've got to make an assumption here You're going to say it hits -2, which it was supposed to. I'm drawing it by hand. -2, great. Less than or equal to y, which is?
Less than infinity.
Right, because it goes all the way up. A bunch of you would stop there. Right? But that arrow goes up, so it's infinity. So how can I write it in this nicer, tidier way? Y is greater than or equal to -2. But what about this open dot right here? It says right there that the dot, their range value of 0 is an open dot. So why am I able to say this? Because this is right.
There's a line that tells you.
Why is this right when that open dot right there says that that point doesn't hit 0? No, I've already told you it's right, Blake. There's more than one point. Doesn't it hit 0 right there? Doesn't it hit 0 right there? So is 0 okay?
Yeah.
Right, because I'm only looking at the range, aren't I? And the range covers everything going up. Got it? So what would it be in interval notation?
Oh, no, -2. No.
What kind of bracket?
Square bracket.
Square bracket, because we said it was equal.
Equals to that, so -2.
Then what?
And then space.
Infinity or in space.
Round. And if we were coding, -2, comma, blank.
And then circle that.
Okay? My coding is a little dodgy. I don't know if you need brackets. Yeah, you do.
You definitely need brackets. And 0.
I haven't coded since 1984. And I know you guys think that there wasn't coding in 1984. But there was. Oh, no. It was
Coding a computer.
It was called Logo. And you had a blank screen and you did a bunch of words. Then you pushed end, and then the blank screen of words would go away, and then there'd be a picture on the screen.
It's like computer coding, right?
Yes.
Oh.
But, like I say, that was 1984. What's funny is it hasn't changed that much.
Yeah.
The theory is still the same.
It's syntax.
Yeah. It's all about syntax. All right. Wow, you guys are good to go. So now there's a problem with your books. Because my drawing or my printout messes up from your books here. I think, and I'm looking at Byron's, that your next thing is
Domain and range review number 1.
yes, and there it is. It's in a different spot. Okay, so here's what I want you to do. I want you to do the domain and range in set or interval. Your choice. Some of them you're forced to use one or the other, right? Otherwise, make sure you can do some of both. But the photocopying's a little dodgy. So follow along with me in your books. The first one, they are obviously both closed dots, so I'm going to make them significantly bigger. I want to know the same thing I've wanted every piece of our notes. Function, yes or no, domain and range. All right? Closed dot. Now that arrow, everybody, I get in a big fight every year. I am saying that arrow flattens out there. Okay? It goes horizontal. But it continues. Okay? Frustrating. plainly visible on my machine as an open dot. Don't know about yours, so I'm fixing it now.
It's pretty obvious.
Yeah.
Okay? We're going to say this one also flattens out, horizontal. Aight? Two closed dots, quite plain to see. Everybody good?
In number two, looks like a banana. The giant compared to the other one, circle, an open one is closed.
In number 2,
Yeah.
they're all closed.
Okay.
Turn on to 176.
Circle. That's don't do this.
Number 2, open dot, but only at that one. Okay? Number 3, closed dot. There is no, I don't want an arrow there. Number 4, 3 open dots.
Is that an arrow?
I'm getting to that. Arrow, arrow. Number 5, 1 open dot. And number 6 is indeed a very crudely drawn, because I photocopied this from a piece of paper where I drew the circle by hand instead of using the machine here, which has a fun circle feature right there. But it is indeed a circle.
Oh, just a massive open dot.
No! I'm going to say that next year! One massive open dot. No, it's a circle. But next year, just for fun, I'm going to say massive open dot. And then go. All right. And then there's a little bit of work.
Gross. Is this one too, though?
Yeah, but it's super easy. What the heck? Where did that come from?
You click the circle feature because you were showing how.
Oh, right. Yeah. It's an open dot. None of this work is included in that set. Right there. Okay? Go. I'm giving you what looks like a lot of work, but it's not really because it takes 2 seconds to do each one. And you have until when?
Friday.
Wrong.
Thursday.
Thursday. 'Cause what's happening tomorrow?
Wednesday.
Cumulative exam.
Take a look at it.
What? Yes, you may look at old tests, or you may work on this, or whatever you need to do.
Mr. Myers,
Oh, what?
really quickly, may I run downstairs to get my jacket? I just left it downstairs.
Wait, what? Wait, are you going to use this too? Oh.
It's on everything to do with exponents, factoring, polynomial expansion, and radical. It's radical is how awesome that test is. Oh, owie, 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 owie.